Hello everyone, welcome to MLAS 700 Advanced Cybernetic Systems Development, and this is our very final learning activity of the term. And let's go ahead and get it kicked off with machine learning development life cycles. So if you've been through our computer systems program at the undergraduate level, some of this is going to be somewhat similar in the sense that we'll be talking about systems, process engineering or process systems development life cycles. And this is something that we cover as seniors in our undergrad for the computer systems folks. But when it comes to machine learning development life cycles, there's some nuances to it that we have to talk through that make machine learning development and systems engineering within machine learning systems a little bit different from your traditional software or systems development life cycles. So machine learning, when we talk about machine learning, there's really a continuum of machine learning development. So it typically starts off on the information or the data side. So we do there are different verticals of what happens on the app, what happens in applied versus what happens in research, what happens in a life cycle is different in different domains. So for example, and the capability within those domains is different. So when we're talking about data analytics, that's really kind of the focus of show me what's going on today in the data, like using data, and I'm observing a natural phenomenon or an organizational system like a corporation, let's say. If I have an organization, an organizational system of people within that, then they create data, and then when I do data analytics on that system, we're talking about what we're talking about is getting a current state view of what is happening today. Typically, we say that's descriptive. So that's descriptive data that just describes what's happening at the moment. But then when we get into data science, we get into, okay, let's create a model to do, we'll do some data engineering on that, and then we'll prep the data and then say, okay, well, let me predict the behavior of what that organization's going to do. And that's typically what a data science exercise does, but they don't, not always, but a lot of times what data scientists will do is they're not emphasizing the operationalization of the model that they're using for predictive classifications or classifications and clustering. It's just whatever it is. It's usually a one-shot analysis, right? They'll do the model analysis, they'll do the model evaluation. And this isn't always everybody. This is just an on average kind of perspective. So that's what a data science realm would look like as it approaches a problem to this organizational structure. Next up is if I'm now going to operationalize what I'm seeing. So in other words, I've created descriptive data, I've created a predictive model, but then I need to operationalize that predictive model. That's typically what happens on the machine learning side. So if I say data analytics, data science, machine learning, that's typically the continuum. Now, that's not always the case. It's just that those are kind of the big buckets. So that's where I want to try to help explain that from a high level. That's where you get into the difference between the analysis, the science and analysis of data that's good at doing model evaluation against the data analytics that are being pulled together descriptively. And then the machine learning side is more on what are we gonna, again, this is kind of the perspective of what you might see on the industry vernacular. Again, this isn't always the case, but that's just what I'm trying to explain from a development life cycle perspective. Okay. So a lot of times when you're looking at software development or systems development life cycles, they're pretty straightforward. Usually you've got a requirements or planning, and then you have an architecture and a design, and then a design and a development implementation, and then you have a testing, and then you just kind of run through that. that whether it doesn't matter if it's an agile method or a waterfall method or a spiral method or a test-driven development method or a rational unified process, they all have these domains. It's how they treat those domains and how they emphasize them at each step. That's really what the big difference is. And in the case of machine learning, when I was talking earlier between data analytics, data science, and machine learning has as its domain is, okay, now how do I operationalize what I'm seeing? Typically, in what we see, and actually we use this in a lot of our project, is a very lightweight agile method, and we use a Trello board, and we have this idea of we have a backlog and an iteration schedule, and we usually have this regular recurrence of deliverables that goes through this plan, collaborate, deliver, and that follows an SDLC mechanism as well. But we emphasize documentation as we move along. So we'll go through testing, design, and artifacts as we're going through the process simultaneously of development. That's not for everyone. It works great for small teams. It doesn't work as well for bigger teams. Like if I'm building aircraft carriers, that's really not realistic, right? If I'm scaling up to that size. If I'm building F-35s, it doesn't scale up well, right? Agile works good in small teams and for smaller chunks of work. As it relates to, let me preface this, that there's no one size fits all. You're going to come across different variations of this. There's going to be different iterations, different tweaks, different little things that you might see. So the base machine learning development life cycle is kind of your starting point. So in this case, you've got machine learning development, and then in terms of a model refinement, continuous improvement perspective, and you're going to almost always see that in a machine learning environment. A machine learning development cycle is a continuous improvement process. When you take data from the real world and you put that into your model, you're going to be constantly monitoring and maintaining that, and you're going to be sensitizing that refinement. You're going to be constantly exploring. You're going to be getting more data and then reevaluating the model, and then you're going to test and evaluate, and you're going to go through this evaluate. This is a very good example of what it looks like from a machine learning perspective. But what's different about machine learning versus SDLC is that model refinement, model evaluation, data evaluation, and then model exploration, test and evaluation. Those are all, the way those all work in the model refinement is that's the tweak, that's the difference. Here's another version of it. This is a V2, and so, like I had mentioned earlier, there's slightly different versions of this, right? And then I'll show you a V3, and that'll pretty much wrap up our final lecture for the semester here. But this one does, we gather data, we do data prep, and then data wrangling. This is another one you'll hear on a kid, like, what's data wrangling? And that's our data prep, right? That's all of our, not data prep, but that's all of our data engineering before going into model train and test. And our data wrangling is now that we've got our data prepped and it's structured, now how do we put it in and get it integrated into our machine learning life cycle. And then as we move along, we have to do that data analysis. And in this case, part of data analysis also means we have to come up with good model evaluation metrics for our machine learning model. I talked about that in our lectures, and I also talked about that in our Python code from some of our labs. Remember that each model has a different evaluation metric, so you have to be cognizant of that and bake that into your development life cycle because it's important. All right. Last is I've got a third version. This is a fun one, a more comprehensive comprehensive one. And I like this because it gives you a kind of a TOGAF view of when I say TOGAF, the Open Group Architecture Framework. It gives you a kind of almost domain view of what that looks like for machine learning from a development perspective. And it's more granular. So I've got data. What I like about this is the roles that it sets aside, but then also it's more comprehensive in the sense of I've got model evaluation, data preparation, feature engineering, model training, and scoring. That is more in alignment with a true, like, down in the weeds, what you might see a lot of times from an ML/AI perspective. And then you've got model productization, you've got productionization, sometimes is what it's called. You also have model deployment, execution, and monitoring. And again, what I appreciate about the way this is set up is this is typically how you would see this in an industry perspective. This is a solid industry view and a solid industry machine learning development life cycle. And another piece of it that I really like is the way the roles are lined up here, right? From business analyst to AI architect to data scientist to ML engineer, this talks through all the pieces that I was mentioning earlier, like from a data analytics to data scientist to a machine learning engineer. This helps to delineate those roles as you move through operationalization of a machine learning model. Okay, so that's all I have for development life cycles. I don't want to belabor it too much more, but I hope you found that useful, just to kind of take a little bit of time and pull our heads up a little bit higher to be focused on more of the process and business aspects of rolling out a machine learning model. Okay, so next steps. You have so shore up any missing assignments you might have. If you've got a missing learning reflection, please get that in. And then you have from now until the 15th to get your final learning reflection in. So please do that and get that going. And then, and of course, look on Canvas and double check the assignment and make sure the assignment has what you need. Or rather, that the assignment is understood by you and what you need. And if you have any questions, feel free, of course, to reach out. And that's all I have. And I appreciate it. I enjoyed it. It was a blast. And if you have any questions or you need a hand with anything, feel free to text or email or reach out to me on LinkedIn. Again, have a good one. Thanks, and we'll talk to you later.